Very good morning and welcome one and all present here on the third session of day 2 of ATAL sponsored 1 week offline FDP on unlocking the future, exploring the transformative power of 5G and beyond from 4 to 9 December 2023 is organized by Electronics Engineering Department, Rajki Engineering College, Sonbhadra. It gives me immense pleasure to introduce and welcome our eminent speaker, Dr. Dharmendra Kumar Dixit from MMNIT Allahabad. I would like to request Abhinav Gupta sir kindly welcome him with a plant. फ्रंट पे सर आ जाओ. हाँ. सर आ जाइए यहीं पे. Dr. Dixit received BTech in Electronics and Communication Engineering from M Gorakhpur in 2007 and MTech degree in Electronics and Communication Engineering from IIT Bhubaneswar, IIT Guwahati, and PhD degree in Wireless Communication from IIT Bhubaneswar, Odisha. Currently, he is working as an assistant professor in the Department of Electronics and Communication Engineering, MNNIT Allahabad, Prayagraj. Prior to join MNNIT Allahabad, he has worked as an assistant professor in Rajki Engineering College, Uttar Pradesh from December 2017 to August 2023. He also worked as an assistant professor in the Department of Electronics and Communication Engineering in LMNIT, Jaipur from December 12 to December 2017. He also worked as a senior lecturer in Department of Electronics and Communication Engineering, JP Guna from July 10 to December 12. He also worked as a scientist as SC in ISRO at Sriharikota, Andhra Pradesh from September 2009 to July 2010. He has also received Best Teacher Award from Dr. APJ Abdul Kalam Technical University, Lucknow. He has published more than 25 research papers in journal of repute in the conferences and journal. Most of the publication is in the IEEE journal and conferences. His research area includes surface, intelligent reflecting surface assisted communication, unmanned aerial communication assistant for 5G and beyond, RF energy harvesting, terahertz communication and fading channel. Sir, we are very glad to have you. Thank you so much for accepting our invitation. Sir, you are requested to kindly start your session with title Performance Study of 5G Communication System in Fading Channels using MATLAB Simulation. Sir, kindly enlighten us with your valuable words. Thank you, sir.
And my topic of today talk is a performance study of a 5G communication system in fading channel using MATLAB. So nowadays we are living in the 5G communication era. It is rapidly this is implemented in other cities, metro cities. Now they will expand to the other places in India. So as an engineer we should know what is the characteristics of 5G and beyond communication, what are the main technology which are going to use in the 5G, and how I can model the 5G systems with the help of MATLAB, okay, to get the insight about the performance of the 5G systems. So the focus was this for my talk. So, outline of this talk is a introduction for 5G and beyond communication, and then I will discuss fading, and then I will discuss how to defeat the combat with the fading impairments. So, that is a diversity concept, and then another method, that is intelligent reflecting surfaces, that is a 5G beyond technology for the communication in wireless. Then I will discuss what are the performance measure we will should evaluate, calculate to know the performance of the communication systems. And then I will discuss MATLAB simulation for diversity combining receivers, and then MATLAB simulation for the IRS aided wireless communication system. So, to start this talk, we go through the evolution of the communication generations. So, this diagram depict the data rate, technology, and the time span of these generations. As we know that first generation denoted by 1G, that was very low rate communication, very small rate communication, and basically application of the 1G was related to the analog communications. Then we move to the multiplexing techniques. We are using the FDMA, frequency division multiple access, and then we move to the 2G, that is started from 1980 to 90, and that is a start of digital era of communication, and they have used the multiplexing techniques, TDMA and CDMA, and 3G, that is started with the digital voice and data. Okay. Before 3G, we are concentrating on your voice communications, and after that we also included one application, data communication. Okay. Data, and main technology was WCDMA, wideband code division multiple access techniques, that is technology for the 3G. After 3G, from 2000 onward, we are using LTE advanced long term evolution and IoT wireless broadband communications in wireless communication, and the backbone technology was OFDM, orthogonal frequency division multiple access techniques. And then we move to the 5G. In 5G, we will find that we are again using OFDM, but OFDM is not, OFDM is going to reach their capacity. Then we have to search for another techniques. You see from this, every generation has a different technology, but in 4G and 5G there is one common technology, that is OFDM. Okay. And now if you want to go 5G beyond, you have to change this OFDM, and that is a OTFS, orthogonal time frequency. I will discuss later in this. In OFDM, in 5G we are focusing on small cell. Small cell means we want more towers. Okay. So we now you are seeing the towers in every city, and in city multiple towers. Previously one tower was supported for one city sufficient, but now they want to data rate, they need high power received signal. So the first thumb rule, you have to increase the number of towers. Okay. And then in 5G beyond, that is nearest 6G, that is going to implement in 2030, and that main technology OTFS, NOMA, terahertz, cell-less satellite communication. We are using cellular communication. In cellular communications, we know that we have to using the hexagonal cells. to coverage the divide the coverage area, and then we dividing for each cell certain frequencies allotting. Okay. So in this self-less communication means we are dissolving, we are not considering the cell concept. So far we are focusing on only cellular communications based upon cell concept. Okay. We want to move from this cellular cell concept wireless communication to without cell concept, means every frequency is available for all person residing in coverage area. Okay. Previously in which cell you are lying, you have to bound to that frequency range, frequency allotted frequency. To understand why people are moving from one generation to another generation, everybody know the Shannon-Kapsky theorem. Okay. That is a very well known theorem for communication engineers, that C equal to B into log 2 1 plus SNR. The unit is bits per second. This is determine the, this theorem tells how fast we can transmit data in a channel. Okay. It decides the limit. So if you see, this formula is a function of bandwidth and SNR. How this bandwidth and SNR changing from one generation to another generation. If 1G, they have allotted a bandwidth. Okay. So bandwidth is allotted, you want to increase the number of user, you have to divide the bandwidth for each users. Okay. Another way to increase this data rate, because the C depend only two parameter B and SNR. So you have to increase data rate, and also you have to increase the number of users for the communications, because every day new users are going to add in that system. Okay. So B, if B is a fix for that generation, then people are try to improve the SNR. SNR improvement require signal processing. You have to process the signal such that it increase the SNR. If this is also increasing, it will also increase the data rate. So every generation we are focusing number of more users and more data rate, yeah, higher data rates, and this theorem tells. So you understand why this, what is the significance of B and an SNR, and we will learn how to increase the SNR. There are multiple methods, diversity is one of methods. Okay. Other signal processing techniques also, OFDM also is signal processing techniques to increase the SNR to combat the multipath fading.
In higher resolutions we have increased the bandwidth, but our channel is the same, because channel bandwidth is same. And
no bandwidth will, I will,
then it will become a frequency selective channel.
In 6G we are expecting frequency selective and delay selective channels, because I will explain in next slide with the example. I am comparing the 5G and 6G. What are the parameters for each generation? One is a peak data rate, what is user experience blue data rate, maximum bandwidth, energy efficiency, spectral efficiency, connection density, and reliability, air interface latency means delay, and positioning accuracy, GPS you are using in it, and mobility, what speed we can communicate if user are moving.
Reliability is related to outage.
Reliability
Is related to outage.
Yeah, 1 minus outage. If outage not reliable, if no outage, you can say that. Outage means we cannot communicate, and reliability, so that how, if there is no outage, we can reliably communicate.
In case our signal is in outage, still can we reliably communicate
No,
our information?
it not guaranteed.
So
Outage,
of deep space communication,
huh?
where signal strength, in case of deep space communication,
Yeah,
signal strength is very
Yeah, because satellite power is limited.
So how we can reliably establish a link?
There are other techniques. They can use the channel encoding techniques so that they can transmit with lower data rates. There you have to compromise. There are other factors which can make sure that we can achieve our goals. Okay. So if you see in 5G we are expecting peak data rate 1 Gbps, but in 6G we are trying to get the data rate 1 terabits per second. Okay, so 1000 times more data rate we are expecting from the 6G. But what is the user data rate? Downlink and uplink. Okay, so if you see the downlink data rate for the user is a 0.1 Gbps in 5G, and uplink data rate is greater than 50 Mbps. Now 10 times in 6G we are expecting this user experience data rate. These are we want to achieve, but we cannot achieve that one. But what we can achieve, that is user experience data rate. Okay. Maximum bandwidth here is 1 gigahertz. Here is 100 gigahertz. Energy efficiency will increase from 10 to 100 times over the 5G, and then spectral efficiency 5 times of 5G. Data rate divided by bandwidth is known as spectral efficiency. And how many user per square kilometer square area we are expecting in 5G? 10 power 6, 1 million user per 1 square kilometer. Okay, and this 10 times greater than 5G, and reliability is also increasing in the decimal point. Okay, air interface 1 millisecond that was expected in 5G, but we are expecting in microsecond in 6G. And GPS accuracy was in 5G expected 1 meter order in 2D. In 6G we are expecting 3D accuracy of centimeter. That is very highly accurately we can find the position of users, receivers. And then in 5G we can support if user are moving at the speed of 500 km per hour, we can communicate with reliability. But in 6G we are expecting we can communicate up in a 1000 km. We can provide the wireless communication in bullet trains also. Okay, that is a. So what are the key technology that will support the 5G and 6G beyond? One is a intelligent reflecting surfaces aided communications. In 4G and 5G we are working on the cooperative communications. They want to replace the relay with the intelligent reflecting surfaces in the 5G and 6G beyond, because these are passive IRS, they do not need any energy. So we can improve the energy efficiency, because more user more energy we needed. Okay, active IRS has certain advantage but complexity, and both are existing, but they want to focus first on passive IRS. If that is not achieved, that not supporting our goals, so will active IRS people are also studying, but just they started with this sim, they want to realize the passive IRS aided communications, because that IRS don't require very small, ideally don't require any energy. In relay require energy, but passive IRS doesn't require any energy. Another is cell free massive MIMO, multiple transmitting antenna, multiple receiving antenna, but now phone has cannot accommodate multiple antenna. That is the biggest, because if you want to increase the antenna in the mobile users, mobile systems, it will you going to compromise with the portability. You cannot in in this you can support, but in this device we cannot support multiple antenna, because battery multiple antenna more energy require, your battery drainage will be problem, and size will increase, that user don't want. Okay, that's why people are putting the wireless access points. In that they are including two antenna nowadays. Okay, so diversity we can apply either transmitter side or receiver side. In massive MIMO, in some cases tower to tower communication we can apply the massive MIMO, because tower is supported by the generator. Okay, mobile is not supported by generator, only battery, and tower can supported by the solar cells also, solar energy also. So we can apply the massive MIMO on tower to tower communication. Okay, so we can apply also massive MIMO, but in mobile we cannot apply. Okay, terahertz band communication, if you are moving from one generation to another generation, you are increasing the frequency. In that case signal attenuation will be high. That is a main thumb rule. If you are increasing transmitting a higher frequency, your signal will attenuated. But we know that we want to more user, we need more bandwidth, so you have to go higher frequency to get the higher bandwidth. Okay, so if one problem, so we will focus that if we cannot decrease the bandwidth, we have to increase the SNR, so that I can achieve the data rate. So there is trade off you have to do. Okay, why we are going for SNR? Because now systems are more power, they are more advanced processors, they can do more computations. If they can do more computation, we can do the signal processing, higher order signal processing, higher complexity signal processing. Okay, and orthogonal time frequency space, it is 2D modulation scheme where we are doing communication in 2D. Why? Because in 6G we want to more higher capability capable processors, they can do this complex 2-dimensional, this techniques can be signal processing of 2 dimension we can achieve on the devices also. Okay, that's why we are looking for the orthogonal time frequency space, where delay and frequency both are selective. Okay, and this is challenging task, but there is challenge, a complexity, you have to look on the higher computational complexity processing schemes. Okay, so now we are moving from high end Intel processors, so we can do this, it is expected. So challenges for the communication is real world deployment induced complexity, particularly in the presence of fading, because one thing, if you want to communicate, if there is a line of sight, that is not issue. Okay, there is less effect of fading, but if there is no line of sight, but in real world we are communicating most of the time null line sight of scenario conditions. If you are signal coming on your mobile, it is coming null line sight communication, because your receiver is not directly linked, not in front of the tower. Okay, so fading is always, so every communication has to if you will want to perform, they have to combat with the fading, and fading arises due to man-made and natural made structures like buildings, trees. Okay,
In case of millimeter band and terahertz band, there line of sight is necessary.
Yeah, that's why more towers are there incorporating. and again now you are taking the geo broadband, that is a optical fiber, and they are putting in device. Now it is in, if you put the access point, you can in line sight. You understand, line of sight guarantee high data rate, and you have to think how I can achieve that one. But it is also that it is not always possible to achieve. Suppose you want to go outside the room, after certain distance, if you are not in line of sight, inner line of sights also exist. But if you want achieve high data rate only if you are in line of sight scenario communications. सो ये आपका ओवरव्यू था, जैसे कि कम्युनिकेशन में सैनन थ्योरम से कैसे हम रिलेट कर सकते हैं कि ये क्यों बैंडविड्थ बढ़ाई जाती है और कौन कौन सी सिग्नल प्रोसेसिंग से हम क्या अचीव करते हैं, एसएनआर इंप्रूव करते हैं. ओके, दिस इज द जिस्ट ऑफ माय टू प्रीवियस स्लाइड. एंड व्हाट आर द key performance parameters, okay, where we compare what we want to achieve. You have to fix the target and then you try to achieve the target, and you have to go look after other techniques and other way how I can achieve. So fading is a very important part and parcel of the wireless communication. You cannot eliminate this. You can minimize, you cannot eliminate this. Okay. So a transmitted signal from a tower, you assume this is a tower transmitter and this is a mobile receiver antenna, single antenna device, transmitter and receiver. This is buildings and other things. So in wireless communication occur due to the three phenomena: reflection, scattering and diffraction. Okay, reflection from ground, या size of the obstacle that is greater than order of lambda of communication. Okay, frequencies, carrier frequency is fixed, you can calculate the lambda. Scattering and diffraction occurs at the sharp edges of the buildings and other things. So a transmitted signal from the transmitter propagate through reflection, scattering and diffraction. It create a multiple copy of the same message. हाइजेनबर्ग वेव प्रोपगेशन का प्रिंसिपल आपने पढ़ा होगा 12th में, कैसे वेव प्रोपगेट होती है. ये भी एक इलेक्ट्रोमैग्नेटिक वेव है, सेम कॉन्सेप्ट से ये भी रिफ्लेक्ट, स्कैटर्ड और डिफ्रैक्ट होके प्रोपगेट होगी. ठीक है. सो एंड वी नो दैट ट्रांसमीटर एंड रिसीवर आर सराउंडेड बाय ऑब्स्टेकल. बिल्डिंग, एनीथिंग इज ऑब्स्टेकल. Human being also obstacle that is reflected from the signal also. We are also reflecting the signals, yeah, absorbing the signals. So due to these reflection, scattering and diffraction, we find a multiple copy of the same message. But what is the drawback is this multiple copy? Each copy has a different phase and amplitude. Okay, maybe reflected signal has power will loss and phase will change. Okay, if you consider it is a complex quantity. Okay, when these are added, they are added, maybe they will added in constructive way or destructive way. आपने light में constructive interference and destructive interference पढ़ा होगा ना. Same thing, it is also occurring in this wireless communications. Okay, if added constructively, you have to it will increase the SNR. If you are not added constructive, it will decrease the SNR, resultant in SNR. But our aim was to increase the SNR. It is clear. So we have to combine suitably so that most of the time constructive interference will occur. Okay, and we will try to minimize the destructive addition of these multiple copies of signal, because it lead to the deep fade and defade communication lead to the outage. If outage simply means signal received at the receiver end is very small, we cannot detect the या recover the message from that signal. जैसे मैं बात कर रहा हूँ ना, उस कमरे के बाहर जाएगा ना तो आउटेज होगा, उसको नहीं सुनाई देगा मैं क्या बात कर रहा हूँ। सिंपल एग्जांपल है आउटेज का। यहाँ पे हो, सब सुन रहे हो मेरी बात, इसका मतलब यू आर नॉट इन रीजन, नॉन आउटेज इवेंट है आपके साथ कम्युनिकेशन मेरा, लेकिन बाहर 10 इस कमरे से बाहर जाओगे वो आउटेज हो गया, क्योंकि माई सिग्नल पावर इज गोइंग टू डिसिपेटेड फ्रॉम द डिस्टेंस. So I might, if you consider I am a transmitter, this is my coverage area. So constructive and destructive combination of these signal lead to the fading. This is definition of fading, and this is a pictorial representation of fading phenomena. Phenomena lead to the fading. So effect of fading, performance of receiver degrade. Degrade means we cannot achieve our required data rate, yeah, we cannot recover the message if deep fade occurs. Okay, we have divided this signal, this fading in two category: small scale fading and large scale fading. Small scale fading, variation in signal amplitude over a area of order of few wavelength. ओके, इसका एक एग्जांपल है, कभी कभी आप बोलते हो कि आप कॉल करते हो और जहाँ पे खड़े होते हो तो आपका सिग्नल पकड़ता नहीं है, तो बोलते हो थोड़ा मूव कर जाओ, तो आप ये नहीं कि 1 किलोमीटर मूव नहीं करते हो, आप 1-2 कदम पीछे करोगे तो देखोगे आपका सिग्नल अचीव हो गया। मतलब वहाँ पे जो सिग्नल एडेड हो रहे थे, डिस्ट्रक्टिव हो रहे थे, आपने मूव किया, वहाँ पे सिग्नल कंस्ट्रक्टिवली ऐड हुए तो आपका एसएनआर बढ़ गया, and एसएनआर बढ़ गया, रिसीवर कैन एक्सट्रैक्ट मैसेज। ठीक है, जब मेरे बात सुन ले रहे हो तो आप, मैं क्या बोल रहा हूँ, आप रिकवर कर जाओगे, लेकिन जो बाहर बैठा है कमरे के वो मेरा नहीं सुन पाएगा, क्योंकि उस ऐसा नहीं कि सिग्नल नहीं जा रहा है, लेकिन सिग्नल जा रहा है, but the power of that voice signal is very small and our ear cannot detect. Ear is a receiver. Large scale fading, variation in signal power over area of order of kilometer. ये क्या होता है, ट्रांसमीटर के साइड से कवर किया जाता है। जब आप टावर से बहुत ज़्यादा दूर हो जाते हो तो आपको सिग्नल ही नहीं पकड़ता है, वो उसको कहते हैं लार्ज स्केल फेडिंग फिनोमेना। ओके, अभी तक बातें समझ में आई है ना? नहीं समझ में आया तो पूछिए, मैं एग्जांपल दे के बताऊंगा, आपको चीज़ें क्लियर हो जाएंगी। आप जब भी टाइम मत वेस्ट कीजिए, बैठ के कुछ सीखिए, मतलब सीखेंगे तो आपको फायदा होगा, ये सब इंटरव्यू में पूछा जाता है। और कोई मैं ऐसा बिग मैथमेटिक्स नहीं डिस्कस कर रहा हूँ, मैं रियल लाइफ एग्जांपल लेके what is the wireless communication, what are the phenomena occurring in the wireless communication, I will try to explain, and then we will see how I can model this phenomena in MATLAB without any hardware and software, only knowledge of computational programming languages. If you understand these phenomena, you can easily model. There are various small scale fading statistics or models available in the literature. I have highlighted few ones. One is a Rayleigh fading, another is Nakagami M, that is also known as RICE. Rayleigh, Nakagami M, and eta mu and Nakagami Q, that is also known as HUT. It is a model to model the propagation scenario, null line of sight propagation scenario. It means transmitter receiver, there is no direct link. Okay, signal are coming indirect way by reflection and scattering, not directly. उसका रियल लाइफ एग्जांपल है, जैसे मैंने उनको बात करनी है, मैं किसी दूसरे के थ्रू करवाऊंगा तो वो आपका नल लाइन ऑफ साइट हो जाएगा। डायरेक्ट मैंने आपसे बात नहीं की, और जब मैं डायरेक्टली आपसे बात कर रहा हूँ वही है आपका लाइन ऑफ साइट कम्युनिकेशन, वन टू वन कम्युनिकेशन. But in propagation scenario it is a used terminology line of sight and non-line of sight communication. Okay. Other model RICE, kappa mu, two-way with diffuse power and fluctuating two-way model are model to model the line of sight scenario. This fluctuating two-way model used to model the millimeter wave communication, that is a 5G communication for 28 gigahertz. Okay, this model used to model the outdoor communication between mobile and tower in 5G communication. At that frequency, carrier frequency should be order of 28 gigahertz. So this is as you know that these are random variable, and random variable is fully characterized by its PDF or CTF. Okay, like LTI system, you understand the signal system. LTI system fully characterized by impulse response. Same way we can say the random variable is fully characterized by either PDF or CDF. Okay, fully characterization means every information regarding the random variable I can extract from that function. As you know that if you know the impulse response, you can find the characteristics of your LTI system. It is memory less, okay, causal, everything, that information hidden in the impulse response expression, yeah, function. So this model, fading model channel is used to model the small scale multipath fading when independent scatterers are sufficiently large with approximately identical energy and no line of sight component. This was first model used to model the wireless channel. This is simplest model and the first model used to model the fading phenomena. Okay, up to 2G that was a very good model to model the fading phenomena. The PDF probability density function of Rayleigh amplitude, that is mod alpha, can be given by this expression, that x should be always greater than 0. This is amplitude and absolute value, it is not negative, it will be positive. That is also called envelope of the amplitude. Omega is omega is the power of the that random variable. That is a variance, second moment, so it is a power. Power is a square quantity, so we can relate it is a omega denoting the power. Rayleigh random variable can be modeled as a complex Gaussian noise. So x and y are complex Gaussian noise of 0 mean and equal variance. Sigma square by 2 is a variance. Okay. So if I will take absolute value of this complex Gaussian, that capital X plus j omega, that will give the Rayleigh faded amplitude of resultant random variable. Okay. Generally MATLAB has given certain basic functions. Okay. MATLAB also has given, because it is well known statement that most of the real world phenomena can be modeled as a Gaussian random variable. Okay. Central limit theorem also tells that if you are like, you know that Fourier series, in Fourier series, in trigonometric Fourier series, we know that any periodic signal can be modeled as a sine and cosine. Okay. Same you can relate here. This is Rayleigh random variable, this is one random variable. We have model in terms of Gaussian random variable. Okay. So Gaussian random variable is a very important random variable So MATLAB has provided this basic random variable. Directly implementing a random variable on MATLAB, it is difficult, but you have used different algorithm. I will tell what algorithm you can use for the directly implement or find the random variable according to that PDF, CDF. We will discuss later. But if available function are available, I want to use that function to realize a new random variable. Okay, a random variable can function among other random variables. Okay, so we have model like this. So if you want to generate a Rayleigh random variable, because if you want to evaluate the performance on MATLAB, you have to able to generate a fading variable, fading channel. So you should understand how I can generate a random variable. So there is a rand n function, inbuilt function you can search, and that can generate a Gaussian random variable of 0 mean and unit variance. Okay, so now if you are adding a complex Gaussian random variable, so I have divided by 1 by square root 2, because I want to the amplitude overall power of this random variable is unity. Okay, that's why I have divided by 1 by square root 2, because power of this is 1, power of this 1, resultant power of this complex signal is a 2, but I want to normalize unity. We will see why you want to do the normalization. So I have to divide by 1 by square root 2. So if you use this command to generate a Rayleigh fading channel. Okay, this is another Nakagami and Rice Rayleigh fading model. This model is also known as a Rice distribution. To model the propagation path consists of one strong line of sight component and many multipath components. So this model is suitable for the line of sight communications. Okay, the PDF of this Rayleigh fading amplitude is given by this expression. This is a complicated expression, and the I naught is the modified Bessel function of first kind and 0 order. The relation between n Rayleigh factor, there is another parameter k to characterize the Rayleigh distribution. K and n are both are related. Okay, now how I can model this line of sight fading scenario, that is characterized by Rice distribution or Rayleigh distribution. Again I will model this Rice distributed amplitude mod alpha as a sum of it is a model a complex random variable x plus jy. Now recall that previously we are using 0 mean, now we are using non-zero mean. Okay, now this term, this is n denote the normalized Gaussian random variable. There is a notation. Okay, so previously we are using 0 mean, now we are using non-zero mean and equal variance. There is also equal variance, but divided by 2, equally distributed, independent, and k is related by v square by 2 sigma square. V square is the power of line of sight component, 2 sigma square is power of line sight of components, a multipath component, a diffuse component. These are terms used to denote the call the line of sight components. Rice distribution now you can model by the complex Gaussian random variable, that mean will be this and variance will be 1 by 1 plus sigma. It can be calculated. So MATLAB command to generate a random variable, Rice random variable mod alpha square root k square root of mean of this complex Gaussian, and then square root 1 by 2 equal, this variance is divided between the two random Gaussian random variable. That's why we have applied 1/2 of this variance. you have to divide. So this way you can generate a Raysian फेडिंग मॉडल. अभी तक मैंने डिस्कस किया दो फेडिंग मॉडल, एक था रेले, एक था राइस या रेसियन या नाकागामी एन. ओके, ये क्यों दो हमने पढ़े? हमने बताया कि कम्युनिकेशन जो होता है वायरलेस कम्युनिकेशन में, उस कम्युनिकेशन को दो पार्ट में डिवाइड कर सकते हैं, एक लाइन ऑफ साइट कम्युनिकेशन, एक नॉन लाइन ऑफ साइट कम्युनिकेशन. ओके, line of sight communication can also occur with the non line of sight communication also. Okay, so Rice is modeling both line of sight plus non line of sight. It means this model include the Rayleigh distribution, Rayleigh fading model. Okay, when it occur, when this mean V is 0, yeah, k equal to 0. If k equal to 0, you see that same expression you are getting that is previously used for the Rayleigh. If k is 0, this term is 0, k plus 1 0, so 1 by square root 1 by 2, and then remaining thing you can compare. This is exactly same. So Rice is a generalized model. It include this Rayleigh model, fading model. Now Nakagami fading model, it is used to model the urban environments. Okay, in urban environment, because so many large buildings, okay, so it is very difficult to get the line of sight propagation scenario or communication scenario. Okay, to model this scenario, how they model this? They do experimentally, they will measure the received signal in that area large, they will collect the samples, they will plot the histogram, and then they will try to model which function can approximate that normalized histogram, and they have, because Rice has modeled that scenario and that name is given Rice, scientist Rice. Nakagami is another scientist. He has taken measurement and he has proposed mathematical model for that histogram, so that's why name is Nakagami. Okay, Nakagami proposed 3 models. Rice is also proposed by Nakagami and also known as. So this is a generalized model for non-line up scenario, propagation scenario. So this is a PDF expression is this. If m equal to 1, you see that PDF expression is equal to the Rayleigh. So you can say that Rayleigh is a special case of this Nakagami also, and that m should always greater than 0.5, not less than 0.5. And this parameter determine the severity of fading. If m increasing, it means fading severity increasing. If determine the fading, no, m is increasing means fading severity is decreasing, means your channel condition is better. If channel condition is better, you get the high data rate. आप भी कभी कभी आप डाउनलोड करते हो, अचानक से आपकी स्पीड बढ़ जाती है. वो क्यों होती है? क्योंकि आपका चैनल कंडीशन बेटर हो गया, इसलिए आपकी स्पीड बेटर हो गई. ओके, it accommodated the Gaussian and Rayleigh, one-sided Gaussian and Rayleigh as a special case. We know that I cannot model this Nakagami easily as a you can say with the help of Gaussian random variable. So you have to find another methods. जैसे कि आपको पता है कि फोरियर सीरीज पीरियोडिक सिग्नल के लिए है, तो ए पीरियोडिक सिग्नल का किससे मॉडल होंगे? फोरियर ट्रांसफॉर्म से. So similarly we know that we cannot model directly as a Gaussian. जैसे कि उसमें भी एक्सपोनेंशियल होते फंक्शन होते हैं, फोरियर सीरीज में भी होता है, फोरियर ट्रांसफॉर्म में भी होता है. ओके, बट उसमें इनफाइनाइट कंपोनेंट होते हैं इंटीग्रेशन इनफाइनाइट होता है। तो इस तरीके से जो चीज आप पढ़े हो उससे कोई भी लेटेस्ट चीज को मॉडल एनालॉजी निकाल सकते हो, उसको रिमेंबर करना बहुत आसान होता है। और पूरी लर्निंग सिमिलरिटी पे बेस है। किसी को कोई चीज बहुत याद रहती है, इसका मतलब है उसके दिमाग में सिमिलरिटी स्टोर करने का, क्योंकि सिमिलरिटी स्टोर करने के लिए बहुत कम जगह चाहिए। जैसे मैं चेहरे को डिफरेंशिएट करता हूँ तो उन चेहरों में कुछ स्लाइड डिफरेंस, उसी चीज को मैं रिमेंबर करता हूँ। मैं किसी को रिकॉग्नाइज करता हूँ तो उस डिसिमिलरिटी से या सिमिलरिटी से ओके रिकॉग्नाइज करता हूँ। उसी तरीके से एक्सेप्टेंस रिजेक्शन मेथड ऑफ जनरेटिंग रैंडम वेरिएबल विद नोन पीडीएफ। सपोज इफ यू नो द पीडीएफ but you are not able to model that PDF, a random variable, as a function of Gaussian random variable, how I can generate that random variable? Because only you can evaluate the performance only if able to generate those phenomena on the MATLAB. Otherwise, how you can evaluate the performance? So suppose ये हिल गया होगा, फिर से करना पड़ेगा क्या मॉडल? सोर्स कहाँ से? ठीक है, इससे पॉइंट करने के लिए है, पॉइंट होता कि नहीं होता?
ये इस पे होगा ना, वो स्क्रीन चल रहा है।
ओके ओके, हाँ स्क्रीन पे नहीं। सो नाउ वी विल स्टडी हाउ टू generate a random variable which random variable is known PDF, okay, which has known PDF. If PDF don't know, you can don't apply this method. That is acceptance and rejection method. This method is also try to generate a random variable with the help of uniformly distributed random variables. We have used different approach to model this new random variable with the help of uniformly distributed random variable. Consider we want to generate a random variable x according to the PDF f of x. The algorithm for this generation of random variable of f of x is this: generate v1 uniform in between 0 to a. Means v1 is a uniformly distributed random variable in between 0 to a. Generate another random variable v2 uniformly distributed between 0 to b. If v2 less than f of x, this b1 is used to model the independent variable of this function x, small x, and this v2 is used to model the value of f of x. Okay. If now you have to, in place of x you substitute v1 and find f of x v1 and compare with the v2. If less than 1, then output will be, means you have generated random variable small x. Small generally notation for capital X to denote the random variable, small lower case is used to value taken by the random variable. Okay, this is a standard notation to denote the random variable and value taken by random variable. It is clear? If you less than this, then I have generated random variable x v1 that follow the PDF f of x. Otherwise, reject v1 and return 2 because that is not generated according to this PDF f of x. So that's why it is called accept and reject method. Because x is set of values, f of x is set of value. Okay, we know that what is the range of x and what is the range of f of x. We have generated two uniformly distributed random variable in the range of x and f of x. We assuming that small x lie between 0 to a, f of x lies between 0 to b. In between your PDF will like this. Okay, a square, a rectangle box, maybe certain curve. Okay, the sample generated below the curve is accepted, sample above the curve, a function f of x, is rejected. That is a concept. Here you have to understand slightly different. Generally in deterministic cases we know that how to generate a function. You have to first choose what is the range of independent variable and then put and you get the dependent variable. Here is the reverse process. You have to generate independent variable based upon dependent variable. That is a reverse thing. You have to generate a random variable that has certain probability. Other deterministic function f of x is not a not modeling the deterministic phenomena. It is a non-deterministic phenomenon, that is a random phenomena. Okay. So you understand generation of two function. This is a not deterministic function. It is a non-deterministic, a random function, because that function used to model the random variable. Okay. जनरली जैसे आपको बोलेगा साइन फंक्शन जनरेट कीजिए तो आप टाइम एक्सिस लेते हो और पुट कर देते हो और कैलकुलेट करके आपका एक साइन ऑफ टी का वैल्यू निकाल लेते हो. ओके, वो भी एक फंक्शन है ना, साइन ऑफ टी इज अ फंक्शन, एफ ऑफ टी इक्वल टू साइन ऑफ टी राइट कर दो, ये भी एक फंक्शन है. बट यहाँ पे स्लाइटली डिफरेंट अप्रोच है, क्योंकि यहाँ पे आपको इंडिपेंडेंट वेरिएबल जिसको बोलते हैं उसको जनरेट करना है अकॉर्डिंग टू द पीडीएफ फंक्शन. इट इज क्लियर? क्योंकि ये फंक्शन यूज किया गया है टू मॉडल द रैंडम फिनोमिना या रैंडम सिग्नल. सिग्नल ही बोलेंगे ना, एफ ऑफ एक्स इज ए सिग्नल. रैंडम वेरिएबल इज आल्सो ए फंक्शन. इट इज नाइदर रैंडम नॉट वेरिएबल आल्सो, because it's map the sample space to the real line या complex plane. And you have to repeat this step 1 2 3 and you have generated your random variable according to that PDF. Follow f of x. अब इसी को मैंने MATLAB में नाकागामी रैंडम वेरिएबल के लिए लिखा है, क्योंकि हमें पता है कि रेले को हम कॉम्प्लेक्स गॉसियन से जनरेट कर सकते हैं, राइस को भी कॉम्प्लेक्स गॉसियन से जनरेट कर सकते हैं. अब एक रैंडम वेरिएबल आया जिसको हम इजीली नहीं मॉडल कर सकते हैं कॉम्प्लेक्स गॉसियन से. ओके, तो हम यूज करेंगे डिफरेंट अप्रोच टू मॉडल. जैसे पीरियोडिक के लिए साइन को साइन ले लिया, एक्सपोनेंशियल ले लिया, पीरियोडिक एक्सपोनेंशियल ले लिया, उसी तरीके से ए पीरियोडिक के लिए आपने नॉन पीरियोडिक एक्सपोनेंशियल लिया है. लेकिन एक्सपोनेंशियल है ना, वो भी एक्सपोनेंशियल है. दोनों में यदि एक्सपोनेंशियल फोरियर सीरीज देखें और फोरियर ट्रांसफॉर्म देखें, दोनों में एक्सपोनेंशियल है. बट बोथ आर बेसिस फंक्शन आर डिफरेंट. उसमें बेसिस फंक्शन की बात करें तो बोथ आर डिफरेंट. इस वाले मॉडल में देखिए आपने क्या किया, रेले और राइस के लिए आपने गॉसियन बेसिस फंक्शन यूज किया. यदि बेसिस फंक्शन के बारे में बात करें तो यहाँ पे नॉन गॉसियन बेसिस फंक्शन, यूनिफॉर्मली डिस्ट्रीब्यूटेड रैंडम वेरिएबल. यही चीज आपको कैलकुलेट, जैसे कि ये है एक्सप्रेशन ऑफ पीडीएफ एक्सप्रेशन ऑफ दिस. टू गेट द, you have taken x1 and you have to find m, r, m is a b, r is a. ओके यहाँ पे मैंने अलग नोटेशन यूज किया है. R इज द रेंज लिखा हुआ है. R is the range of independent variable x of f of x, and m is the maximum value of PDF for fixed m. Okay, so A and B have you if compare with the that algorithm A and B, you relate the R and M. So we have generated rand n function in build function in MATLAB. Okay, that is generate in following distributed random variable 0 to 1. Okay, 0 to 1. I want to generate a random variable that range light between 0 to capital R. So just you have to multiply R with the U1. Then you have generated V1. Okay. Similarly for V2 case, you have generated U2 that generated between 0 to 1. Now you have to multiply with M, so you get V2. And this is initialization counter, because you have to accepted things stored and rejected things you have to discard. Okay, so I will use a counter, initialize the counter and check for each value of the sample, and then increment the counter and save outputs and do this. If you call this function, you will get the Rayleigh distributed random variable. Okay, अभी तक पहले हमने सीखा था अभी तक कि what is the 5G beyond communication, what are the generations, what is the main challenge. Main challenge is fading. फेडिंग क्यों आकर होती वो सीखा हमने, और फेडिंग को हमने दो कैटेगरी में डिवाइड किया, स्मॉल स्केल फेडिंग एंड लार्ज स्केल फेडिंग. अब मेन फोकस है स्मॉल स्केल फेडिंग. स्मॉल स्केल बहुत सारे मॉडल्स होते हैं, क्योंकि उस फेडिंग को हम जब MATLAB में जनरेट कर पाएंगे तभी हम वो मॉडल कर पाएंगे उस वायरलेस सिनेरियो को. ओके, या वायरलेस कम्युनिकेशन सिनेरियो को. ओके, तो वी हैव gone through the different type of line propagation scenario and suitable model for the propagation scenario. Line of sight propagation scenario, another is learn line of sight plus line of sight scenario, and we have learned how to generate these fading models. Okay, now diversity combining receiver. तो जो सेटेलाइट पे टावर रहता है वो तो टावर होता है ना. नहीं, फेडिंग का आता है, उसमें भी इशू आता है. कोई भी चीज़ नहीं है कि जहाँ पे फेडिंग का इशू ना आए. यूर लाइन ऑफ साइट में भी फेडिंग होती है. ऐसा नहीं कि लाइन ऑफ साइट अचीव कर लिया तो फेडिंग नहीं होगी. एग्जाम्पल बताएं, मैं आपसे बात कर रहा हूँ, साइड वाले बात कर रहे हैं आप इसके बगल में. हर चीज कंट्रोल नहीं कर सकते ना.
सैटेलाइट और ह्यूमन बीइंग के बीच में एक आइनोस्फीयर होता है ना.
हाँ, वहां से रिफ्लेक्शन स्कैटरिंग डिफ्रेक्शन होता है. बादल हैं, ये नहीं करेंगे.
शायद नाकागामी क्यू को.
हाँ, ह्योट को सैटेलाइट कम्युनिकेशन के लिए मॉडल के लिए यूज किया जाता है. जैसे कि क्लास में हम ये कभी नहीं कह सकते कि सारे बच्चे अच्छे हो जाए, ये जरूरत भी नहीं है. नहीं तो अच्छाई और बुराई साथ में हो तो भी अच्छाई की महत्व है, नहीं तो. लेकिन कोई चीज बहुत ज्यादा नहीं होनी चाहिए. कोई भी चीज एक लिमिट में हो इट इज एक्सेप्टेबल. सेम चीज यहाँ पे वायरलेस कम्युनिकेशन में ऐसा नहीं होगा कि कोई मतलब चैलेंज ही नहीं है. तो फिर कम्युनिकेशन आप चाहो 100 Gbps या 1 टेराबाइट 1000 टेराबाइट से डेटा रेट ले सकते हो, कोई जरूरत ही नहीं है. तो लाइफ में कोई चैलेंज नहीं है तो उस लाइफ का कोई मतलब नहीं है. सोच के देखिए, सब कुछ मिल रहा है, आप सोचते रहोगे, कुछ नहीं करोगे. नहीं तो 6G तक लोग, आप डिग्री ले रहे हो, बीटेक में डिग्री बंद हो जाएगी यदि इसका मतलब सब कुछ इजी हो गया तो. कुछ लोग सोचते हैं चैट जीपीटी आ गया, पढ़ने की जरूरत नहीं है. वो बहुत ही गलत सोचते हैं. आपको ज़्यादा पढ़ने की जरूरत है, बिकॉज नाउ मोस्ट ऑफ द वर्क्स डन बाय द मशीन्स and you have to become smarter than machine. That is not easy task. And don't become slave of machine, you become master of machines. Otherwise you will face a lot of challenge and you cannot achieve your goal also. So डाइवर्सिटी आपने सुना है, यूनिटी इन डाइवर्सिटी इंडिया का मेन कॉन्सेप्ट है. इसी तरीके से किसी क्लास में डिफरेंट टाइप के बच्चे हैं या किसी सोसाइटी में डिफरेंट टाइप के लोग हैं, सबका अपना अपना वर्जन होता है. यदि उनको हम उनकी कैरेक्टरिस्टिक्स या उनके अच्छाइयों के साथ किसी काम को अचीव करने मिला के, उनकी अच्छाई बुराई मिला के हम काम करें तो अचीव कर सकते हैं काम. सेम चीज डाइवर्सिटी रिसीवर करता है. कोई वीक है, कोई स्ट्रांग है. यदि बहुत आप स्ट्रांग भी हो लेकिन कोई एक बड़ा टास्क है, अकेले नहीं कर सकते, लेकिन एक बहुत स्ट्रांग एक वीक कैन डू द टास्क मे बी. एंड डाइवर्सिटी रिसीवर is doing the same thing, because maybe multiple copies are available of the signal due to the reflection scattering. Okay, you have to combine suitably so that I can increase the SNR. We know that if you are able to increase the SNR, you can get better quality of service and higher data rate. Okay, so in diversity combining, two or more independent copies of the same message bearing signals are suitably combined to improve the total SNR. This is the idea. Maybe one signal has a weak, very weak in comparison to another signal, but if you combine suitably, we can get higher. In other words, diversity combining is a practical approach to mitigate the effect of fading in wireless channel. जैसे किसी प्रोजेक्ट को मैं दे रहा हूँ तो एक वीक स्टूडेंट है और एक स्ट्रॉन्ग स्टूडेंट है, मतलब गुड स्टूडेंट है. हो सकता प्रोजेक्ट इतना बड़ा हो कि स्ट्रॉन्ग स्टूडेंट भी सिंगली नहीं कंप्लीट कर सकता, बट इफ दे बोथ विल रेडी टू वर्क टुगेदर, they can achieve that, they can do the project. Same thing doing the diversity receiver. Is it good to bad and good and bad? Both are okay, but you have to judiciously combine or suitably combine, then you can achieve. So exploit the low probability of occurrence of deep fade in all the diversity channel at the same time. It is also possible कि जो क्वालिटी आप में हो वो क्वालिटी उसमें नहीं है, लेकिन जो क्वालिटी उसमें है वो क्वालिटी आप में नहीं है. ओके, और किसी काम को करने के लिए हो सकता है वो दोनों क्वालिटी जरूरत हो. आपको वो क्वालिटी अचीव करने में टाइम लगेगा या रिसोर्सेज लगेंगे. आप ये कह सकते थे क्यों वीक सिग्नल को ले रहे हो आप स्ट्रॉन्ग सिग्नल को, सो यू आर वेस्टिंग द टाइम एंड वेस्टिंग द रिसोर्सेज. डाइवर्सिटी है तो यू हैव टू एक्सप्लॉइट द डाइवर्सिटी, नो नीड टू पुट एडिशनल रिसोर्सेज. व्हाई यू आर वेस्टिंग एडिशनल? बिकॉज यू हैव टू रीट्रांसमिट द मैसेज एंड वी एक्सपेक्ट दैट सिग्नल विल that fading will not occur in deep condition, deep fade, severe fading condition will not occur. Okay, so reduce the probability of error या outage probability. Probability of error या outage probability you can reduce by suitably combining the multiple copy of the signal which have different power levels. In terms of signal strength is measured in terms of power levels या energy levels. So this is a block diagram of diversity receiver systems. Multiple receiving antenna. There are three main diversity combining scheme: maximal ratio combining, equal gain combining, and selection combining. These are three varieties of diversity combining receiver. Other also available: generalized selection combining, okay, switch diversity, okay, switch and stay combining others, but these are basic main types of diversity combining receiver. So if I will model this diversity receiver in the block diagram, so I will use two combining block and detection block to detect the output bits. Which bit what? In digital communication, we are doing the digital modulation at the digital demodulation, okay, to get the know which ones and zeros was transmitted. A combination of ones and zeros transmitted. So combiner may be either selection equal gain combining with L antenna. We are assuming generalized L antenna. Now maximum 2, 3, 10 antenna is sufficient, but we want to study, so we consider a generalized model. Okay, L can be 1, not 0. Okay, without receiving antenna you cannot. आपके पास कान नहीं है तो नहीं सुन सकते. Okay. So receive complex baseband signal at the Lth receive antenna of the combiner can be modeled as this. This is modulated message. Now this term mod alpha L and exponential j phi L is the fading model. To model the fading, fading is a multiplicative effect on the transmitted message, and noise is additive effect. There are two effects considered to model the received signal at the receiver end. X was transmitted by the tower. Now channel is this modeled by this function mod alpha into exponential. This is a complex quantity, so it is written in amplitude and polar form it is written. Okay, this is noise NL. Each antenna has a AWGN noise. Okay, this is short noise बोलते हैं. Electronics noise जो होती है उसको मॉडल किया short noise से. X is constellation point of a modulation scheme because digital modulation is fully characterized by constellation diagram या space signal space representation. Now is fading amplitude या envelope, and this is the phase. The phase lies between 0 to 2 pi. Angle 0 से 2 pi ही unique होता है. Okay. And this is n is a complex Gaussian noise with 0 mean and variance n naught. So complex Gaussian random variable. This is. So now we have to define SNR. Receive SNR at Lth antenna. This portion is a signal and this portion is noise. So SNR is a signal power divided by noise power. So NL is a Gaussian noise. A Gaussian noise, a Gaussian random variable power is a variance of 0 mean. Okay. So this is power. Now this is complex quantity. If you will take absolute value and then square, that is a power. Okay. So the power of X will be ES. It may be symbol or bits. Okay. So ES into take absolute value and square, then mod X. If you take absolute value of exponential, that is 1. So this is instantaneous SNR definition. Okay. ES is the power of X, average power of the constellation modulation scheme, and naught is the power of the noise NL. The average power you have to, this is random variable. So first expectation is known as average power, and that is modeled as this, and this will be. So output of combiner can be mathematically expressed the principal operation of combiner. For linear diversity combiner, a general expression of R can be given as linear combination of all the received signal. So that mathematically is CL is the weighting factor into received signal YL, and that is the output of the combiner, and that combiner output goes to the detector. Okay. And based upon CL we can find MRC, selection combining and equal gain combining. Okay. So combining coefficient, CL is known as combining coefficient, and take value according to the combining rule applied. Maximum ratio, this is a selection combining receiver. I have selection combining, select the signal which has highest SNR. Okay. So Y1, Y2, YL, SNR monitoring and choose maximum. They will measure the SNR by that formula. They can calculate the SNR and then decide which one has highest SNR, that will selected by the switch, and that is R, and then goes to detector, and that detector will be, detector are two types of maximum likelihood detector and maximum a posteriori detector, digital detectors. So for selection combining, CL can be, there is only one is selected, then it means that CL is 1, otherwise CL is 0, because one was selected. So I can mathematically model this. When L is equal to K, that selected, then that will be 1. If the L equal to not, that will be 0. That is mathematically how can model the selection combining combiner output. Okay. Now if in terms of SNR, output of SNR receiver is the max of gamma L. There each signal has a, each branch has a SNR gamma 1, gamma 2, gamma L. So this is mathematically at a max of gamma L, where this is defined as this. From the implementation point of view, this is simplest of all diversity combining. It is a simplest diversity because it is required to process only one branch. So simple. If you have to process the multiple branch, that is more complex, but we get the better SNR. Now is a maximum ratio combining, that is known as optimal combining technique. Yeah, and that provide maximum, a highest SNR at the output of combiner. So but the complexity is more. You have to co-phase with the channel information. You have to measure the CSI, channel state information, means channel coefficients, and suitably compensate those channel, equalize the channel to minimize the effect of fading. Then it will get a result. Fading effect is minimizes, means you are going to expect higher SNR. So you combine this, this is get the R, and detector give the output weights in case of binary. Mathematically it can be, CL will be complex conjugate. We taking that CL as a complex conjugate of each channel. Channel is model a mod alpha L exponential j phi L, but conjugate will be the mod alpha L exponential minus j phi L. So weight to be conjugate of channel gain must be estimated. You have to channel estimation, you have to apply in the MRC. That is a complex and additional feature, additional things you have to do to get the better SNR. The combiner output can be written as this, CL into this. If you substitute gamma L and simplify, I can write like this. So this is a signal part and this is noise part. So calculate the combiner SNR. This will be this, similar to the single branch case SNR. If you model this, ES by N naught will common, and this will be if you divide by this, I can write like this also, sum of SNRs of each branch. So MRC combiner provide optimal performance and need all the fading information at the receiver. That is complex, lead to the complex receiver, because you should able to estimate the channel paths. The complexity of communication receiver with the MRC combiner is high. So this is our diversity combiner. Diversity combiner still we are using in 4G, 5G, because wireless communication is happening due to diversity combiners. If this concept was not, we cannot do the wireless communication. Okay. Now in new techniques, that is intelligent reflecting surfaces. Up to 5G we are assuming that we cannot control the wireless environment, but now they have coined the concept we can control the wireless environment, and that is lead to the this intelligent reflecting surfaces, because in channel what is happening, reflection, scattering and diffractions, and these multiple copy are added constructively or destructively. So we don't have a control on constructive interference and destructive interference, but 5G onward they want to control on this constructive interference and destructive interference with the help of this concept intelligent reflecting surfaces, because fading, if signal constructively added means they added with the same phase. If two signal added with 180-degree, resultant will be 0. Two complex vector both has a 180 phase, if you add, result will be 0. It means phase play a very important role in the constructive and destructive interference. This idea is very, so they want to, with the help of intelligent reflecting surfaces, they want to change the this phase, neither receiver side nor transmitter side. They want to control this phase at the in wireless medium.
So for that there is requirement of
Reflectors
channel CSI
at the receiver IRS.
at the IRS, but our IRS has a limited processing capability. So how
They are saying the to, because CSI is required also at the receiver end. If you want to coherent detection require also CSI. So they say that they will use a separate unit near to the IRS, that is microcontroller based unit. You have to share, maybe tower can measure the CSI, and it by backbone by the wire they will transmit the they connect the just a relay is also connected with the tower.
but relay have a some computational
That has require energy. They are separate unit, that is control the connection between transmitter and IRS, and they will send the CSI to the IRS, and IRS will change the phase according to that CSI.
IRS also need a channel state information
Huh.
receiving and also user side also.
Both, then it can be constructively added
They have to send the value of precise
to IRS. That is a concept. It is not fully implemented, but possible. They have shown in the initial findings. Because IRS is PISO, it cannot do anything computations. So they are using a separate microcontroller based unit that will do these works with smaller power in comparison to the relay. IRS is a competitor of the relay communication. So they have, because they have introduced, because relay is also creating diversity, reflector is also creating diversity.
IRS I think it make a beamforming type.
Beamforming, because relay, if you are using multiple antenna, each antenna has RF channel, more power required. Here is no RF channel in the IRS, so we will get better energy efficiency, and they don't require any resources from the transmitter and receiver side. Means they not in, because biggest disadvantage of cooperative communication is spectral efficiency loss, because resources share between transmitter and relay. Here is not. That is also called full duplex communication, and half duplex is cooperative communication, half duplex communication.
Means you are saying that at the same time and same frequency, IRS can receive.
They will reflect. That's why there is no ADC and DAC, so there is no noise amplification in the IRS.
So it is like amplify and forward relay.
Similar to the amplify and forward relay, not exactly
Full duplex.
because they are full duplex. They don't require any bandwidth or time slots. Signal will fall and reflect. Signal will fall and reflect. So full duplex communication. Full duplex means better spectral efficiency. So this is the concept of IRS, and I have motivated why we need IRS and what is the basic principle behind the IRS. You want to achieve a constructive addition of the multiple copy of the signal at the destination or receiver end. That constructive interference controlled by a constructive addition of the signal controlled by this unit IRS, intelligent reflecting surfaces. So they will know the channel condition of CSI of the both hop. Is it dual hop communication? I will show this is simple. This is applicable where there is no line of, there is no direct link between source to destination. Maybe this link is blocked. In basement communication, other things somewhere they will do. These are just tiles denoting the reflecting elements, and behind that tiles there is a unit that will given to the CSI, and that will on and off of these. If you assume this is a diode, on and off.
It's look like a
patch antenna. Reflecting, that concept was reflecting antenna was in the communication domain. Reflectors, same, they are choosing a reflecting in a very small size.
How we can adjust the phase with the help of this IRS of each element?
There is physics behind these things. Metamaterial surfaces, the antenna part that I don't know in detail, but in the overview at the physical layer, it is, you just assume it is reflecting element, and it know the angle of reflections, okay, and according to he will be change the angle of
reflection can be known. I think
it is very
antenna array.
it is also reflecting elements array, and that can be easily placed on the buildings or all those things, like a painting like this.
So with the help of antenna array we can
It can be like this. जैसे लग रहा है ना, ये आप इसको कंपेयर करो तो ऐसे लगेगा. तो बिल्डिंग्स पे जो बड़ी बड़ी बिल्डिंग्स है उन पे पेंट के या उसका सीट फॉर्म में आएगा एंटीना, यू हैव टू जस्ट पेस्ट, जैसे पोस्टर टाइप का चिपका दिया. So it is n elements, both S and D have a single antenna, and direct path is blocked between source to destination. HL and G are representing the fading channel coefficient between source and Lth element. Suppose this is Lth element of this IRS element, so HL is the channel coefficient of this half, and this is second half. Okay, you can recall the relay communication. In place of IRS there is one relay, but they are transmitting not in same time slot. Relay will transmit another time slots. Here is no time slot. That's why it is called full duplex. You are not sharing the resources either in bandwidth or time. Multiplexing in frequency and time domain both. So we are not doing. So this is IRS assisted dual hop communication system without a direct line of sight. So the baseband receive signal model can be like this. This is a channel due to the reflecting element. This is combination because sum of all those reflected element paths at the receiver end, and that can be written. If you write in matrix form, it can be written like this, and matrix H and G will be this. Okay. So if are these phi 1 theta 1 known to the IRS, okay, then they will use this phi matrix, diagonal matrix, and they will suitably combine. So resultant will be this expression instantaneous SNR. Okay.
Can we use multiple IRS at the same time?
Yeah, but then you have to use select the IRS because more channel state information will require, complexity will increase, but it is a
So if we talk about its
possible.
mathematics, we have to add all the channel between different elements.
Yeah.
Means we have to add another summation.
This expression is very similar to equal gain combining. In equal gain combining, in selection maximization combining, square of amplitude and then sum. But in equal gain combining, we have to sum the amplitude of channel coefficient and then square ES by N naught. If you recall the equal gain combining and selection maximization combining, this expression is very similar to the only difference is it is a product of two channel coefficients. In selection combining, equal gain combining, there is one channel coefficient. Because that is one half communication, it is dual half communication. Whatever technique, that's why I am saying that without diversity we cannot do the wireless communication. There is no substitute.
Mathematics will be more complex because
The equal gain combining analysis, as you understand,
add it and then square it.
because you know the equal gain performance analysis of selection combining and maximum ratio combining is easy in compared to the equal gain combining. Equal gain combining is sum of random variable, not square of square and sum. That is very easy. So this is instantaneous expressions. Now we will discuss performance measure. Why we need performance measures? Because before implementing the any communication system model, you have to thoroughly understand the performance of that communication system, then you can successfully launch that communication system. Why performance measures? Because these performance measure provide valuable insight into design of the wireless systems. You know the what data rate you can achieve, what should be the SNR required to achieve that data rate, what should be the bandwidth, okay, how many users we can support, okay, everything you can do theoretically first, and then we try to implement in the software and then go for hardware. Okay, easy calibration of wireless system parameters. Suppose you want to increase the antenna, how many antenna you can increase per targeted performance, okay, everything easily we can can achieve by the calibrating the wireless system. There are so many performance measures, but my focus on only three main performance: average SNR, outage probability, average symbol, and bit error rate expression. There are three methods. I have mentioned only two methods. By simulation, we can evaluate the performance measures, and by statistical analysis or random process analysis, a random modeling. Another is a field measurement. फील्ड मेजरमेंट से भी आप परफॉर्मेंस मेजर्स को अचीव कर सकते हो. जैसे कि आपके यहाँ जब भी आप जियो फाइबर लगवाने के लिए बुलाते हो तो वो पहले बोलेगा कि ओके तभी है जब वो मेजर करता है, एक डिवाइस लाता है उससे मेजर करता है, SNR बहुत सारे पैरामीटर मेजर करता है और देखता है इट इज ओके एक्सेप्टेबल लेवल पे है तो बोलेगा कि आपका कनेक्शन स्टेब्लिश हो गया, और जब भी कोई दिक्कत होती है वही आके मेजर करता है, तो दैट इज फील्ड मेजरमेंट. So that is not our focus, so I have not mentioned that. Okay, their device you have to measure the bit error rate and outage and all those things, average SNR. So statistical analysis method are PDF based approach, MGF based approach, CDF based approach. So mathematically we can define outage probability is a probability that SNR falls below certain threshold. So P outage is defined by this event. Probability of gamma T is the output SNR at the combiner at diversity receiver at the receiver int. Mathematically, if you want to integrate, you have to solve this integral. If you know the CDF, PDF, you have to integrate the PDF. PR is the probability operator. Gamma is threshold SNR. You have to choose 1 dB, 2 dB threshold SNR. If below that, we cannot, a receiver cannot perform the recovery of the message. So we have to choose. This is PDF output SNR. Gamma T is the receiver diversity combiner output SNR. जैसे combiner में gamma हमने SC MRC लिखा है, ये gamma T है generalize. Because sometimes their random variable has three parameters: PDF, CDF. That parameter is natural domain of the random variable. Another is a moment generative function, that is a Laplace transform of the PDF. Okay, sometimes in some scenario maybe we directly we can get the MGF. Okay, because we know that in time domain convolution is very difficult, but in Laplace domain that can be model multiplication between the convolution of Fourier Laplace transform of each random variable, each function. Okay, so you have to switch from the time domain to frequency domain. Laplace domain is one form of frequency domain representations. Okay, so moment genetic function based approach. Suppose you know the moment genetic approach. So if you take inverse Laplace transform, you get this. Okay, MGF of random variable is this is Laplace transform of this gamma T. S is the Laplace variable, and this is indicating the inverse Laplace transform operator. This is another relation. So one way you can achieve calculate the outage probability by integrate. Theoretically you have to solve this integral. Another way to find the inverse Laplace transform using this relation. Okay, now evaluation of average symbol error rate, average bit error rate, that is also known as average bit error probability or average symbol error probability, both are the synonym. So PDF is approach, you have to average the conditional bit error rate over the PDF of this. Okay, conditional bit error rate is bit error rate in AWGN channel. This is conditional SNR modulation is scheme in AWGN channel. AWGN channel is known as a wired communication. In wired communication there is no fading. Wireless communication is fade. In wireless communication fading is present. In wired communication there is no fading. That's why optical fiber data rate is very high, because there is no fading phenomena. But I cannot use wire everywhere, because wire disturb the portability, a comfort of the user. Okay, so this way, and CDF, suppose sometimes CDF will be easy to evaluate the CDF of at the receiver in. So we can also calculate the bit error rate using the CDF expressions. This is first derivative of conditional bit error rate in AWGN. Another approach, MGF based approach, that is mathematical formulation, that is derived from the PDF based approach. Most of the modulation scheme coherent modulation scheme, bit rate can be written in terms of Gaussian Q function and error complementary function. Okay. So MGF based approach for non coherent modulation scheme, just using the MGF. If you know the MGF of SNR, you can find the beta rate of the non coherent modulation scheme, because generally non coherent modulation scheme conditional beta rate in exponential form. If you are PDF substituting this, it look like is a Laplace transform of this integral in Laplace transform, exponential e power minus st f of t, here f t is a gamma. Okay. So this is theoretical. Sometimes we want to analyze the performance at the good channel condition, that is also mathematically it is considered a very high SNR. So that is in that is also known as asymptotic analysis of the performance measures. We are assuming that gamma bar tending to infinity, a very good quality of SNR. In the high SNR region, we can write the expression of outage and beta rate in this form, and their GC and GD denote the coding gain and diversity gain of the diversity order of the that communication system. Diversity gain diversity order also, physical meaning of this is how many independent paths signal reaching at the destination at good channel conditions. More path signal are reaching at the destination, we know that chances of outage is very less. If outage या deep fade is a less probable, communication occurring. जैसे कि आप जहाँ पे आज कवरेज एरिया में हो तो आपको आउटेज नहीं होता है, जैसे ही कवरेज एरिया आप चाहते हो कि आउटेज ना हो. ओके. Diversity gain is essentially number of independent fading channel compromising the given system chain. Coding gain depend upon the system parameter, code and channel coding techniques, block code, LDPC code, convolution codes. Okay. Diversity gain also determined by the ACR ACR curves. You are plotting the curves from without doing the mathematical calculation. We can also, by measuring the slope of that curve, we can also get the diversity order, that is negative slope of this curve. There is a plot between beta rate versus SNR. SNR should be in log scale. Then if you use this formula, you can get diversity order from the curves without calculating these mathematical expressions. These are modulation schemes and their applications. And if you want to 1 Mbps in WLAN, we for this standard BPSK is recommended. Cordless phone and paging system, frequency shifting we are using. QPSK used for the high data rates up to 11 Mbps in this IEEE standard. 3G WCDMA also using the QPSK. Now 4G onwards, we are recommended to use the QAM of higher order, because you know that QPSK can transmit per symbol 2 bits, but if higher order of QAM can transmit multiple bits. Okay, so we can get a higher data rate. High data rate means higher order of modulation scheme, but drawback of higher order modulation scheme, complex signal processing. Complexity of signal processing will be better, but we know that we are getting better processors, we can do that complexity, we can handle the complexity. So क्या टाइम हो गया, 12 बज गया, 6 स्लाइड बचा, लेकिन कोड अभी ठीक है. Now we will learn how to model, how to evaluate the performance of a wireless system. So first we will model try to selection combining receiver base. Okay. So suppose I want to evaluate the outage probability of a selection combining receivers. What requirement to model this? First you should know what is the baseband received signal model. Okay. What is the formula of instantaneous SNR and SNR at the output. These three things if you know, with the help of these three things we have to calculate the outage probability. Outage probability mathematical definition is this, but what is the meaning of this? It means I have to model a event, okay, random event, like suppose you want to toss the coin, that is a random event, it may be head and tail, but you have to toss the coin. So you have to generate this event on the MATLAB, and then you have to find when this event occurs. Okay. So for simulation, simulated outage probability is defined as the total number of outage event divided by total number of events. It includes outage plus non-outage. Okay. So to know this, you have to generate first you have to generate gamma SC, but gamma before generating gamma SC you have to generate gamma L. Okay. It is clear. So this gamma L depend upon ES by N naught is known as average SNR. Okay. This term is a random variable, you have to generate. If tossing a coin, it may be head and tail. Okay. Same way you have to generate this random variable. Okay. And then you have to calculate the instantaneous SNR and then find max of that SNR for L branches and then compare this with the gamma threshold. Okay. And then you calculate the simulated outage probability. I will show the code. So I have written this same information that is written in slide, I have replicated here for just ease of reference. So MATLAB code of outage probability in relay fading. The relay fading is very simple fading model that can be easily generated. Okay. So these are CLC, clear, close all, and TIC to measure how much time I will take for this simulations. So number of receiving antenna I am considering L equal to 2. Okay. How many instantaneous antenna you have to generate? Gamma 1 and gamma 2. It is clear. But you have to perform this experiment on large set for Monte Carlo. Okay. So number of sample for simulation I have considered n equal to 10 power 6, 1 million. Okay. Then multiple SNR label you have to do this experiment, then your result will be correct. Okay. Then you can analyze the your outage performance. Okay. Then I have taken SNR in dB 0 to 30 dB range up to increments. Okay. Then threshold SNR in dB I am considering 0 dB, that I will consider in linear scale in without dB. So using this formula I can generally 1, but I have this code is valid for anyone. You can change the gamma threshold, you get the different results. Okay. Now SNR in linear scale I have converted with using the formula log से non log scale पे आपको convert करनी है. Okay. Outage this variable या vector outage underscore and non outage event vector store the number of outage event and non outage event for each SNR values. Okay. Another vector I have defined outage and non outage event vector, that is vector of length of, first you have to in this slide in this event you have to count the events outage and non outage. First you put 0 value, okay, for initialization. Then total outage event vector store the, this is total outage event vector, that is store the number of outage events, okay. Now I will run the for loop for the each SNR values, okay. So that is II 1 to length of SNR dB, okay, for each SNR. Now generate relay channel coefficient of 0 mean and unit variance, power is 1. Now S2, then gamma 1 will be the SNR in linear scale multiply with the complex conjugate, because mod alpha square, that can be written conjugate of that alpha into conjugate of alpha. Alpha here is represented by H, okay. So conjugate of this, so gamma 1 is generated, okay, of 10 million gamma 1 generated, okay. Gamma 2 10 million is generated with the help of this command. Now gamma MRC is the max of this gamma 1 gamma 2, it is clear. So it will give the gamma SC as the maximum SNR among these 10 million. They compare 10 million of gamma 1 gamma 2 and find which one is the maximum. It may be either gamma 1 or gamma 2, and that is stored in gamma SC, it is clear. And then compare the SNR with threshold of gamma SC less than gamma threshold. This give the, where this is event less than gamma threshold, that is 1, if it is true it is 1, it is false it is 0, okay, because I have to count number of outage event, means true events, yeah, favorable events, that is definition of probability, because outage is a probability. So total outage event vector you have to sum once, because in this vector outage and non outage event vector has a ones and zeros, 1 representing outage event, 0 representing non outage event, okay. So there is a command sum, you have to sum the ones, because 0 is already 0, sum adding 0 result will be 0, that will give outage event, number of outage event. And then I have to calculate the simulated outage probability, that is total outage event vector divided by number of samples, you have to 10 power 6 samples, and that will give the, then theoretically I can calculate this, I have not because it requires more times, theoretically I can calculate it as this. In selection combining, outage probability is a product of CDF of each SNR, okay. Identically I am considering, then it power is L, okay. So if you compare and plot, I will get the outage plot simply. I will show, run and show this. IRS same code I have written here. See, this is nature of curve. I have chosen very less number of, because at high SNR I require more experiment, more samples. So you can see the theoretical solid line and start denoting the simulation. Both are matching. Why this is not matching? We have performed the perform this experiment less number of samples. Suppose theoretically probability of head at tossing a fair coin is a 0.5, but you are doing experiment only 10 times tossing and measure the calculate the probability of head, you will not find the 0.5. You have to calculate up to 1000 a million times, then you can find that probability reaching to the 0.5, okay. So how I can model this event, probabilistic event? you have to generate the random variable and do the processing. What is the doing by the combiners and generate those event selection combining and compare to outage, and then you have to do the simple calculation you can find. So suppose company is what is the how I can analyze what information we can extract from this plots. Okay, suppose some company is guarantee that if you are buying my so that outage chances will be the 10 power minus 4. If they are claiming, it means they will maintain 20 dB SNR minimum at the receiver end. Okay, so these are informations, simple information you can extract. If your L branch, how many branch you needed, transmitter, receiver, they can design, and they know the what is the pros and cons of the choosing the system parameters, antenna, fading conditions. Okay, this way we can do. Idea is you have to y equal to h into x plus n. You have to model this one. You have to know how to generate n, how to generate x, how to generate h, and then you have to generate y, that is a that is form of this h into x plus n, and that model for the flat fading condition, not frequency selective. Frequency selective cases multiple type channel model. Okay, we have considered single type for simplification, but this can be extended to the multiple channel. In place of multiplication, it result to the convolution. Linear case. That is that non-linear model divided into smaller L type linear model, because it is difficult to analyze the non-linear system model replicate, but I can divide this linear model into smaller non-linear model, smaller linear models. Approximation. Similarly, bit error rate. Bit error rate case, you have to understand the constellation. In bit error rate case, you have to generate the constellation diagram also. So I have chosen the BPSK, that is simplest modulation scheme. So constellation diagram will look like this. EB is the average energy of the BPSK modulation scheme. If EB is 1 units, it will be -1 and +1. So whatever ones and 0 is mapped into the 1 and -1. That BPSK modulation means in baseband case modulation, 1 is mapped to the +1, 0 is mapped to the -1. If this is data, I will consider this is BPSK model. Detection rule, maximum likelihood decision rule, is how to calculate the simulated ABR and ACR. Total number of bits and symbol in error divided by total number of transmitted bits. It include error bits plus non-error bits, like a outage divided by outage plus non-outage events, conditional case. So this way we can calculate same model. So in case of this, to simulate the ABR and ACR, you have to implement this decision rule also, maximum likelihood decision, equal probable case. You are assuming that a large set of 1s and 0s, both are equal probability of generating 1s and 0, like tossing a coin million times, it is expecting equal number of heads and tail. So to implement, you have to, in outage probability we are implementing these two equation in MATLAB, but in case of bit error rate case, you have to implement this equation and apply the combining techniques and then apply the detection rule. You understand what is the difference between simulation of outage and bit error rate? Both are probability. So if I will so this is a MATLAB code. Number of constellation point for simulations. Digital modulator at the transmitter side. Data bits store in T. Rand 1 greater than point. It will generate array vector of ones and zeros. Okay, random ones and zero have equal probability. Now generating BPSK constellation using this formula simply 2 into d minus 1. जब 0 होगा तो minus 1 हो जाएगा, d जब 1 होगा तो plus 1 हो जाएगा. Simple. Yeah, anyway you can generate other way. Now you calculate average energy, absolute value. Generally minus Euclidean distance का average होता है, sum of Euclidean distance divided by number of constellation point. There is 2 points S1 and S2 here. Okay, so 1 and minus 1, Euclidean distance from origin is 1, a square of 1 is 1 plus 1 divided by 2. Average energy of BPSK in case of minus 1 and plus 1 is 1. You can easily calculate the mean and absolute value concept, you get the same thing. Okay, as theoretically you can take. Now multiple SNR value S hat. S hat store the estimated symbols. Now number of receiving antenna, selection combining 5 I have taken. Nth means n best means nth best equal to 1 means maximum SNR case, selection combining. There is also combining scheme where second base, third base, fourth base branches may be selected, because sometimes estimated that estimation of the SNR depend upon available CSI. Maybe CSI is not correct. Okay, there are multiple reasons. Then you will get the wrong branch. We are not getting maximum SNR. Your second best SNR you can estimate and you can process that branch. But we are here doing the best SNR case. Now how many branch antenna using this concept, and then for loop for the number of antennas and also number of SNR values. Noise is generated, channel is generated, SNR dB is linear scale. I have converted. Standard deviation AWG noise sigma you have to calculate. We have assumed that ES is 1, so you have to calculate the generate the for given SNR you have to generate noise of given SNR. Okay, so you have to calculate, because Gaussian noise power is calculated by the standard deviation. Square of standard deviation is the power of Gaussian noise. Okay, so now you have channel and noise, because you have multiple channels, so multiple signals you have to receive. Then channel and noise addition H into SD plus sigma into n to model this, because L is a 5. So I have to written in this in vector form, so that it can be all 5 branches y1, y2, y3, y5 is generated using this single command. H is a matrix, SD is a matrix, N is also matrix. LIJ 5 cross N matrix is generated. Okay. Now you have to find the power of channel, because if you power of channel depending directly proportional square of absolute value of the channel coefficient. Okay, because SNR is mod H square ES by N naught, ES by N naught is SNR. So that instantaneous SNR is directly proportional to the power of channel. Power of channel means H into conjugate of a complex quantity power. Complex quantity power is calculated by this. Okay, so you have to calculate the power, because you have to find the which channel has a highest SNR, which channel square value mod h square value highest, that is a SNR is highest. Okay. Then finding the maximum power using this command sort and descent, it will sort all the channel coefficient according to the highest to the lowest descending order, and then you have to find the which channel among the 5 coefficients, channel coefficient which has a maximum value, and you have to find which channel indexing also you have to store. So using this command you can do these things, and then you have to select the channel chain with the maximum power using this command, and then you have to equalize by y select, you have selected highest received signal, and then divide by h select to equalize, and then reshape, and then BPSK demodulation logics. For a decision region, you have a binary case, you have to draw the perpendicular bisector between -1 to +1 that pass through the origin. Okay, that is maximum likelihood decision region. So this condition is greater than 0 if received signal value greater than 0. I will assume that 1 was transmitted. If received signal value y hat is less than 0, I will assume that my 0 was transmitted. Negative value is mapped to the 0 and positive value mapped to the positive value. So this way I can get the d hat, means estimated data bits, and using this command I will find where they differs. Okay, you have ones and zeros, that was originally minus d hat, that is estimated by the selection combining. If they where they differ, you have to find the numbers on which how many times they differs, that is a corrupted bits. If they once is flipped to the 0, okay, 0 is flipped to the 1, you have to compare and find where they differ. Differ means the bit in error. Okay, and then number of errors is stored in this vector divided by simulated bits, and this way you can do this. बस लास्ट एक same thing I have written. Maybe the difference because with that theoretical value is differ. Okay, this is bit rate simulation for the maybe so this way we can simulate the concept performance of the wireless system. It maybe sometimes it takes, because you are doing so many experiments, so it will take time to get the result. Any doubts? हाँ, but comes 10 million.
Any questions from audience side? Okay, thank you so much, Dr. Dixit. He's actually my colleague from 2010 and one of my best friends. And he has given.
He is senior of my.
When I was in IIT Guwahati, then he is doing MTech there. So we have done a lot of work in same field. So we have done a lot, many collaboration to each other. And here he is selected in MNIT Allahabad. That is a good opportunity for us because the resources there in the MNIT Allahabad that will definitely come to our RDC Sunbelt, and he promised us to well equipped us from the resources which is in MNIT Allahabad. He will evaluate that resources in RDC Sunbelt and give the benefit to all the students also.
Yes.
So in this talk, he has given a very good concept of fading, which is the major problem of the wireless channel, because in the presence of fading we cannot reliably transfer our information from one place to another place. He has discussed various diversity combining techniques and its mathematical modeling, and he has also discussed a very recent topic on the intelligent surface, large intelligent surface. This technology will be utilized in 5G millimeter wave, and I think in the terahertz band also, because in these bands communication become a very short range. Within a fraction, within a meters, your signal will be fade. So in this case, that
Human can also produce the fading, because absorbed by this high frequency signal can be absorbed by the humans around you.
So transmitting higher power is not always a good solution, because it actually hazardous to our health also. So whatever signal we have transmitted, if it is reflected from the intelligent surfaces and all the signal which we have transmitted in a wireless channel, because wireless channel is broadcast in nature, whatever signal we have transmitted, it is gone everywhere. So why not we collect all the signals and direct it towards the receiver, so that we can utilize its all energy. So at last, at the end I would like to request Dr. Dixit to facilitate
PK.
Dr. Bhavna Arora to facilitate Dixit from
Exchange.
love.
Thank you. भैया सर आइए.